log. So here is what we call the stoichiometry roadmap, and it shows us how to convert from whatever units we are given into whatever units we want. So how many moles of NH3 can be made from 0.780 moles of H2? So this is what we were working on last time, where we converted moles of hydrogen into moles of NH3 ammonia, just using our mole ratio here. So this will give us our answer. But what if I'm not given moles of hydrogen? What if I'm given grams? And what if I don't want moles of ammonia for my answer? What if I want grams of ammonia or liters of ammonia? So in this problem, we have our 6 grams of hydrogen to start. And we want to convert that eventually into liters of NH3. So our units given here are our 6 grams of H2. And the units that we want are liters of NH3. So in order to do that, I'm going to need to take those units I was given, convert them into moles. Then I can do a mole ratio to get moles of ammonia. And then I can do another conversion factor to get liters. So this is our plan here. So the way that we would set this up, we would just need to start with our 6 grams of hydrogen. My first step, I want to change grams of hydrogen into moles. Then I want to change the moles of hydrogen into moles of ammonia. So that's going to be our mole ratio. And then I want to convert moles of ammonia, since this is a gas, into liters of ammonia. So first thing we have is grams and moles of hydrogen. So this is the molar mass of hydrogen, which is about 2 grams. And then we have our mole ratio, which is still 2 to 3. And then I need the molar mass of ammonia, or actually I don't because I'm converting to liters. So I just need to know that 1 mole of any gas takes up 22.4 liters. So let's take a look at this question here. First, I'm going to go ahead and make sure my equation is balanced. And we need to think about how we're going to solve this problem. So I want to know how many grams of lithium are needed to produce 10 grams of lithium chloride. So going back to our stoichiometry roadmap here, we're going to need to take those grams and convert them into moles. So that will be our first step, convert this into moles. Once we have moles of lithium chloride, we can convert that into the moles of what we're solving for using a mole ratio. And then I can just use molar mass to go from my moles to my grams. So we can go ahead and set this up. First, I want to change grams of lithium chloride into moles. So grams of lithium chloride goes on bottom, so those units cancel. Now I want to change moles of lithium chloride into moles of lithium. And then finally, I can change my moles of lithium into grams, since that's what the question is asking for. So my first conversion factor here is grams and moles of lithium chloride. So I'm going to need the molar mass of lithium chloride. 1 mole of lithium chloride weighs 42.4 grams. Next we have moles and moles, so that's my mole ratio. So that's 3 to 3 in the chemical equation. And then lastly, I have grams and moles again, which means that I need the molar mass this time of lithium. So 1 mole of lithium weighs 6.941 grams. So in order to solve this, we multiply everything on top together. So 10 times 3 times 6.941. And we're going to divide that by everything on bottom. So I'm going to multiply 42.4 times 3. And then the answer we get here is 1.64 grams of lithium. So at the heart of this, we're still doing that mole-mole stoichiometry conversion. Okay, so let's take a look at question 2. So this time we're starting out with our 30.5 grams of lithium chloride, and I want to know how many grams of aluminum do I need in order to form that amount of lithium chloride. So we're starting here with our grams of lithium chloride. I want to change it into moles of lithium chloride. Then I can use my mole ratio to convert this into moles of aluminum. And then I can use molar mass to convert it into grams. So starting with my 30.5 grams of lithium chloride over 1, first I want to convert grams of lithium chloride into moles. Then I can use my mole ratio to convert this into moles of aluminum. And then I can use molar mass to get grams of aluminum. So our first conversion factor here is grams and moles of lithium chloride. So once again, that's going to be the molar mass here for lithium chloride. So 1 mole of lithium chloride weighs about 42 grams. Next we have our mole ratio. So from our previously balanced equation, there's 1 mole of aluminum for every 3 moles of lithium chloride. Lastly here, we've got grams and moles again, but this time it's aluminum. So the molar mass of aluminum, 1 mole, weighs about 27 grams. So this will give us our answer here of 6.47 grams of aluminum. So in question 3, we need to write a chemical equation. So I've got tin 2 oxide, so that's SNO, reacting with nitrogen trifluoride to produce tin 2 fluoride, and dinitrogen, that means 2 trioxide. So this equation isn't balanced. I can look at fluorine and I can see that. So I'm going to need to put a 2 in front of this guy and a 3 in front of this guy. So that'll give me 2 nitrogens and 6 fluorines on both sides. So then now I need to put a 3 in front of this guy to balance my equation. And then there's just a 1 here. So our plan for this, we're going to start with that 36.52 grams of SNO. We have to convert that into moles. Then we can convert that into moles of NF3. And then we can convert that into grams of NF3. So that's our plan here. So starting with my 36.52 grams of SNO, my first step is going to be to convert grams of SNO into moles of SNO. Then my next step is to change moles of SNO into moles of NF3. Then finally, I can convert moles of NF3 into grams of NF3. So my first blank that I need to fill in has grams and moles of SNO. So I need the molar mass of that tin 2 oxide. So 1 mole weighs 134.7 grams. Next we have a mole ratio. So we're going to look at our balanced chemical equation in order to determine what this ratio is. So for every 3 moles of SNO, there are 2 moles of NF3. So our last conversion factor here is grams and moles, which means I need the molar mass of NF3. So 1 mole of that weighs about 71 grams. So this will give us 12.83 grams of NF3. The next question is a little bit different because we're asking for molecules. So we're starting with our 51.3 grams of SNO. Of course, change that into moles. Then I can change that into moles of N2O3, and then I can change that into molecules of N2O3. So 51.3 grams of SNO over 1. I'm going to convert my grams of SNO into moles. Then I can convert moles of SNO into moles of N2O3. And then I can convert moles of N2O3 into molecules of N2O3. So first I have the molar mass, which we already established was 134.7. Then I have a mole ratio. This is 1 to 3. And then 1 mole is always 6.02 times 10 to the 23rd molecules. So we get 7.64 times 10 to the 22nd molecules here. The last one, we're just looking for moles. So we're starting with the 17.89 grams of N2O3. Going to convert that into moles of N2O3. And then convert that into moles of SNF2. So starting with my 17.89 grams of N2O3, first step is going to be to change grams of N2O3 into moles. Then we can convert our moles of N2O3 into moles of SNF2. So first thing we're going to need here is going to be the molar mass of N2O3. So that mass is about 76 grams. And then we need our mole ratio, which is 3 to 1. So we'll get this answer here whenever we solve. Okay, so theoretical yield is exactly what we've been calculating. So I've got 2 problems here where I want to know how much of this FeCl3 am I going to be able to produce from 3 liters of chlorine gas. So we're going to take 3 liters of chlorine gas, convert that into moles of chlorine, then I can convert that into moles of FeCl3, and then I can convert that into grams of FeCl3. So starting with my 3 liters of chlorine, I'm going to convert liters of chlorine into moles. Then I can do my mole ratio to change moles of chlorine into moles of FeCl3. And then finally I can change my moles of FeCl3 into grams of FeCl3. So my first conversion factor here is moles and liters. So 1 mole of any gas takes up 22.4 liters of volume. Next I have a mole ratio. So I'm going to look in my balanced chemical equation to get that. So I need to balance this equation real quick here. So I'm going to put a 2 here and a 3 here, which will give me my 6 chlorines on both sides. And then I need to put a 2 here to take care of iron. So this ratio is going to be 2 to 3. Last conversion factor here is the molar mass of iron FeCl3. So we get 14.48 grams as our answer here. So if everything goes perfectly and we start with 3 liters of chlorine gas, we should make 14.48 grams of FeCl3. In B, we're going to be calculating grams of FeCl3, but this time we're starting with grams of iron, which will convert into moles, which will convert into moles of FeCl3, and then into grams, just like we did with the previous question. So I'm going to start with my 15.0 grams of iron. I need to change grams of iron into moles of iron. And then I can use my mole ratio to change moles of iron into moles of FeCl3. And then finally convert my moles into grams. So the first conversion that we have is the molar mass of iron. So 1 mole of iron weighs 55.85 grams. Next we have our mole ratio, which is 2 to 2. And then we have our molar mass of FeCl3. So here I get 43.57 as my answer. So this is how much I could make if I started with that 15 grams of iron and then everything went perfectly. So if we know the theoretical yield, which is how much we could make if everything goes perfectly, so that was 14.48 grams here, and 43.57 here. So this is how much I could make. So I'm going to take how much we actually made and divide it by how much we could have made and multiply by 100 to get our answer here. So I get 91.16%. Here we made 40.56 grams. We could have made 43.57, which means that our percent yield was 93.09%.